Let's look at another example of using related rates to solve an application problem. So here we are pretending that we're blowing up a balloon, and this balloon is increasing in volume at a rate of 300 cubic inches per minute. When the balloon's radius is 3 inches, how fast is the radius increasing? So the first sentence is how we set up our equation that involves our related rates. And then the second sentence is about asking us what we want to find at a particular point in time, at that specific scenario that we've been looking at. So let's take a look at what we have. We are blowing up a balloon, so we're going to assume that we have a spherical balloon. So there's our spherical balloon. Now, we know that this balloon is getting bigger and it's increasing in radius as we blow it up. So let's again draw our radius. And that radius is going to be labeled r. It's not a fixed quantity, so we will label it with a variable. Now, we're relating the volume and the radius. So what's the volume of a sphere? The volume is 4/3 pi r cubed. And again, we will differentiate this with respect to time. So the left-hand side will be dv dt, and then the right-hand side we have d dt of 4/3 pi r cubed. So dv dt equals, and now the 4/3 is constant, so we can bring that outside of the derivative. And so we have dv dt equals 4/3 pi. And now the derivative of r cubed is 3r squared. But be careful, r is an inside function. It's a function of time. So we have to take the derivative of the inside using the chain rule, or applying the chain rule. So now let's simplify the right-hand side. So we have dv dt equals 4 pi r squared dr dt. So here we have our equation that relates the rates of dv dt and dr dt. Now let's look at our specific scenario. In this specific scenario, we can now use information given to us. 3 inches is the radius, and we have the volume is changing at a rate of 300 cubic inches per minute. So dv dt is 300, and r is 3. So substituting these values into our equation that relates our rates, we obtain 300 equals 4 pi times r squared times dr dt. So this gives you 300 equals 36 pi dr dt, which means that dr dt equals 25 over pi. And now let's write our final answer in terms of a sentence. The radius is increasing rate of 25 over pi inches per minute. Now, how do we know the units of inches per minute? dr relates to the radius, so therefore that will be inches. dt relates to time, and so therefore that will be in minutes in this problem.